sections 11.7 and 11.8. We're doing an abbreviated version of these sections, just going over some basic concepts here, but this is it. We've reached the end. This is the last we're doing this year. Here we go. Let's talk about the surface area of a right cone. A surface area of a cone, okay, this is a right cone, that is found by adding the area of the base, which is a circle, pi r squared. We already know how to find the area of a circle. But the area of the cone that wraps around the side, not including the base, is pi rl, where r is the radius of the circle, pi is pi, and this lowercase l just represents the length from the tip of the cone to the side of the circular base. So let's apply that and find the volume of this cone. So if I'm finding the volume of this cone, I'm sorry, I'm not finding the volume, I'm finding the surface area. Got a little ahead of myself. We will find the volume, but first we're finding surface area. Surface area is going to be pi, 3.14. We're using that to approximate. R squared, so 3 squared, which would be 9, plus pi RL. So pi, 3.14, times the radius, 3. Now L, remember that represents the length from the tip of the cone to the side of the circle. In this case, it is 5. So again, we use a calculator. So the surface area of that cone, 3.14 times 3 squared is 9. So that's 28.26. And I'm going to need to add that to the 3.14 times 3 times 5, which is 47.1. And this is area, so my units are going to be squared in the end. So when I add those two numbers together, I get 75.36 meters squared. So that's the surface area of that cone. It's a pretty straightforward formula. If you were given all this information, there's some more challenging problems where you have to use some things that we learned earlier in the year with right triangles, but we're really not going to get that in depth to it. Next, what about the volume of a cone? The volume of a cone is 1/3 pi r squared h, where h is the height of the cone. 1/3 pi r squared h. That's the volume of a cone. So here we go. Find the volume of a cone. The volume is 1/3 pi, 3.14, r squared, where r is the radius. The radius in this one is 9.5, so 1/3 pi r squared h, and the height is 16.8. It is now a calculator problem. Just type this in your calculator. Make sure you square the 9.5 first, then multiply by everything else. So the volume will be 1,586.96, and now it's volume, so our units need to be cubed. So the volume of a cone is 1/3 pi r squared h. Volume of a cone is 1/3 pi, so 1/3 pi. The radius in this cone is 4.5, 1/3 pi r squared, and then the height of this cone is 12. And it now turns into another calculator problem. First, square the radius, then multiply everything else, and you'll get the volume of this cone is 254.34 feet cubed. Okay. All right. Find the volume of the solid shown. Okay, well, this is a composite solid. So we know to find the volume of the whole thing, I just need to add together the volume of that cylinder. Let me draw a little cylinder there. That's beautiful. Plus the volume of the cone. I need to add those two volumes together, right? So the volume of a cylinder, which we learned in a previous section, is pi r squared. In this case, the radius here is 3, so I need to do 3 squared. And then h, what is the height of the cylinder? The height of the cylinder is from here to here, so that's 7. So the volume of a cylinder is pi r squared h. And now we need to add the volume of a cone. And we just learned that the volume of a cone is 1/3 pi which we'll use 3.14 again, r squared. The radius of this cone is the same as the radius of the cylinder, so that'll be 3 squared. And then we have to multiply by the height of that cone, and the height of the cone is 3. So to find the volume of the composite solid, it's the volume of a cylinder, which is pi r squared h, plus the volume of the cone, 1/3 pi r squared h. So use a calculator. The volume of the cylinder is going to be 197.82. The volume of the cone is going to be 28.26. So all you got to do now is add them together to get the volume of that composite solid is 226.08. And again, this is volume, so our units are going to be cubed. And that pretty much wraps up what we're doing in 11.7. So let's move on to 11.8, which is all about spheres. Spheres. Okay, we've got 2 formulas to learn about spheres. Pretty much straightforward. The surface area of a sphere is 4 pi r squared. The surface area is 4 pi r squared. The volume is 4/3 pi r cubed. Again, these are the last formulas we're learning, so make sure you have a nice list, a piece of paper of all your formulas on one piece of paper covering the whole chapter. It's going to help you out a lot. So you can look at it and refer to it and say, all right, what shape do I have? What formula can I use? You're more than welcome to use that to help you understand all this stuff. It'd be great if you have it in one location. So find the surface area of this sphere. Well, the surface area of a sphere is 4 pi r squared. So 4 times pi, and the radius of this sphere is 7. So it's just a calculator problem. 7 squared is 49. 4 times 3.14 times 49. The surface area of that sphere is 615.44, and its area, surface area, so our units will be square units, centimeters squared. So that's just a pretty much straightforward application of the formula. Surface area is 4 pi r squared. What about volume? Let's do a pretty much straightforward application of the volume. Volume of a sphere is 4/3 pi r cubed. So it's going to be 4/3 pi times the radius cubed, and the radius in this sphere is 3, so it's 3 cubed. And remember, 3 cubed means 3 times 3 times 3. Does not mean 3 times 3. It means multiply 3 itself 3 times, so that'll be 27. So it's 27 times 3.14 times 4/3. You can use a calculator, and you should get 113.04 millimeters cubed. Okay. This one says find the radius of a sphere with a given volume. Well, we can use that formula backwards. Remember, volume is 4/3 pi r cubed. We can use that formula backwards to find the radius. If we know the volume is 91.95, that represents the V in the formula. That's 4/3 pi times r cubed. So what you want to do first is you want to divide both sides by 3.14 to get rid of that. Divide both sides by 4/3, which is the same thing as multiplying by 3/4. And you get your whole number, or not your whole number, your numerical answer over here to be 21.96 equals r cubed. And remember, a couple sections ago we said, oh, if we have something that's cubed, to find out what r is, we take the cube root. And based on your calculator, if it doesn't have a cube root key, you can raise it to the 1/3 power. So the radius is going to be approximately 2.8 centimeters long. Find the surface area. Well, guys, look, the surface area is 4 pi r squared. I think I'm missing a drawing here. Yeah, I'm missing a drawing here. Actually, I know what happened. We consolidated some old notes and took out some problems, so there was originally a problem here. So on your notes, I'm going to fix that before you even see it, but I'm just going to make this go away. So for our video purposes, it's going to be weird. Anyway, find the volume of the composite solid. Okay. Well, look, this composite solid is a cylinder with a scoop taken out of it, and that scoop taken out of it is part of a sphere. It's half of a sphere. So if the volume of a sphere, look at that. If a volume of a sphere is 4/3 pi r cubed, how would we find half of a sphere? Well, we would just take half of that. So that's how you find the volume of half a sphere. So that's, which is called a hemisphere. So the volume of a hemisphere is found by using the same formula, but multiplying it by 1/2. So let's talk about what this composite solid is. The volume of the composite solid is the volume of that cylinder minus the volume of that hemisphere. Okay? So, volume of a cylinder is pi r squared h. So it's going to be pi r squared h minus the volume of the hemisphere, the half the sphere that's scooped out. So if half a sphere is scooped out, it's going to be half the volume of that sphere. So half 4/3 pi, and then the radius cubed. The radius of that sphere is the same as the radius of the cylinder, so that would be 3 cubed. The volume is going to equal 141.3 minus the volume of that hemisphere was 56.52. So the volume is 84.78 inches cubed. The radius of a sphere is 2.4. Find the volume. Okay, that's a straightforward application of the formula. Volume of a sphere is 4/3 pi r cubed. So in your calculator, cube that 2.4 first, multiply by 3.14, multiply by 4/3, and the volume is going to be about 57.88 centimeters cubed. Find the volume of the composite solid. This is similar to the one we just did. The other one was a cylinder with a hemisphere scooped out of it. This is a cylinder with a half a sphere added to it. So I need to add the volume of the cylinder. There's my cylinder drawing. It's pretty terrible. And now we're going to add the volume of that hemisphere. They kind of look the same. So, volume of a cylinder is pi times the radius squared. The radius of the cylinder is 5.8 times the height. The height of that cylinder is 14. Plus, now remember, it's half a sphere, so it's going to be half the formula for a sphere. So 1/2 the 4/3 times pi times the radius cubed. The radius of the sphere is the same as the radius of the cylinder, so that's going to be 5.8 cubed. So now it's a calculator problem. The volume of the cylinder is 1,478.81. And the volume of the hemisphere is 408.43. My handwriting is just getting better and better. If you add them together, the volume of that composite solid is 1,887.24 feet cubed. And this concludes the notes for geometry. You did it.